let's study about Docker architecture, right. So, if you see here, Docker follows client server architecture. Docker uses client server model. Okay. So, see, I have a client here, Docker client, and then I have Docker what we say, the server. This is the server part, this is the client, and I have my registry here. Okay. Let us see this diagram and understand, then we will go and understand each of these concepts. In client, from client I can run some commands, I can say docker run, docker build, docker pull, these are commands. Client could be anyone, you or me, anybody who is working with Docker are the clients. This is Docker host or the Docker server, where there is a Docker daemon. What is a daemon? Daemon is a backend process. In operating system we studied about daemon, right. See, daemon, I am creating images for what? For Python, right, and then I am putting those images into containers. All that is possible inside the Docker host, that is Docker server. Okay. Daemon is the one which is taking these commands, executing them and doing the tasks. Daemon is responsible for taking these commands, following the instructions and doing the task. It could be creating an image, creating a container, pushing this image into the container, all that, right. What is registry? A registry is a place where I can put all the images. See, I am having images here, all these are the images. How did I create image? Using Docker software. How did I create container? Using Docker, right. So, we can, and we have we call this as Docker hub. It is a place where all your images are stored. Okay. It is a directory, it is a folder where all your images which we have created are stored there, right. So, this is the simple architecture, let us understand in detail. The Docker client talks to the Docker daemon. How? Using commands. How am I talking to the daemon? From the client using the commands, okay, which does the heavy lifting of building, running and distributing your Docker containers. Daemon is responsible for lot of stuff, for creating image, for creating container, for pushing this image into the container, for everything daemon does it. The Docker client and daemon can run on same system, or you can connect a Docker client to a remote Docker daemon. So, the Docker software could be in any operating system or in any machine. Client could be anybody, it is you or me, from anywhere we can access the Docker, right. The Docker client and daemon communicate using REST API over Unix or Linux sockets over a network interface. Again, I am talking about Unix and Linux here, right. That is why we said we can create Docker, we can create container, we can create images only in Linux operating system. Okay. So, only we have studied those Linux fundamentals at the beginning, right. Another Docker client is Docker Compose, that lets you work with applications consisting of a set of containers. We will understand this more in detail. What is Docker Compose? We will see, right. But I am just trying to explain you here that Docker daemon is the main component of the Docker architecture, which is responsible for creating containers, image, packing, everything is done by the daemon. Daemon gets the instructions from the client, somebody like you and me giving these commands, right. And we know what is registry. Okay. What is Docker daemon? The Docker daemon listens for Docker API request and manages Docker objects. What are Docker objects? Image, container, network, volume, all these are Docker objects. So, what are listens for Docker API request? Who is sending the API request? Client. When you give a command to the Docker, right, that is the command is given to daemon. Daemon takes that command and manages the objects. Let us say you are giving a command to create a container, it will create for you. You tell to delete a container, it will delete for you. right. So, a daemon can also communicate with other daemons to manage Docker services. Okay. So, this is another important aspect in Docker architecture. Docker daemon can also communicate with other daemons, other backend processes to manage the Docker server services, because maybe there may not be one daemon is working, there may be multiple daemons working parallelly, okay, handling different requests from different users. So, they can talk to each other, that is what it is telling. Then we have Docker client. What is Docker client? Is primary way that many Docker users interact with Docker. Client means we are interacting with the Docker, right, to create, to delete, right. When you use commands such as Docker run, the client sends these commands to Docker D. Docker D means Docker daemon. See here, Docker D means Docker daemon, which carries them out. As simple as that. I am giving a command here. This command is taken from, I am giving, client takes it and gives it to the daemon. Daemon executes it. The Docker command uses the Docker API. Okay. When I give a command, that command is through the API request, it is sent to the daemon. Docker client can communicate with more than one daemon, that we understood it, right. So, this is another component. The third one is Docker desktop. All these are the components of a Docker architecture. Docker desktop is an easy to install application for your Windows, Mac or Linux environment that enables you to build and share containerized applications and microservices. Okay. So, basically it is a software, it is a front end tool. Docker desktop includes Docker daemon, Docker client, Docker compose, Docker contest trust, Kubernetes and credential helper. All these things, once we install Docker desktop, you will see all these things in that application, in that interface, through which we can create the containers. Okay. You will understand this better once you see the real demonstration. Okay. Then something called as registry, we know this. Docker registry stores Docker images. Okay. Docker hub is the public registry that anyone can use, and Docker looks for images on the Docker hub by default. When you use the Docker pull or Docker run command, Docker pulls the required images from your registry. When you use push command, Docker pushes your image to the registry. So, basically it is like the GitHub. It is like the GitHub where we put our images there and we get our images back. Whenever you want to put some image into registry, you will put in the Docker hub. After 1 week of testing, your testing was successful. Now you want to switch that from your testing environment to the maybe UAT environment. You can again pull it, okay, and send it to the next environment, right. So, that is the that is possible only if you put the images in the registry. Next, Docker hub. What is this Docker hub, right? I am saying that Docker hub is a registry, right. So, it is a repository service and it is a cloud based service where people push their Docker container images and also pull the images anytime or anywhere, like our GitHub. Whenever we want, we can get the images from the repository. Whenever we want to upload, we can, or you want to commit, you can commit them back. Why are we doing that? So that other developers want to use it, or you yourself wants to take that image from one environment to the other environment. That is possible only if you put that image in the repository. Okay. If you put the image in the repository, only then it is possible to switch it, right. So, let us see this image here. If you see, this is my Docker hub, a registry stores many static images. Okay. Let us say you are pushing. So, I am having a Docker file, all commands to assemble an image, all commands which are required to create an image. I will do the build, I will create an image. After that, these images I want to run, I will put them in the container. Okay. This we know that. if I want to run some program, this is the sequence, right? Code, from code I get the image, this image I put in the container, and we play with these containers always. Container contains the image, image has all the code of that application. Okay. So, Docker file is one important component here, which contains, so code plus Docker file together will help me create an image. See here, Docker file will help me build an image. This image to run I will put inside the container, right? Image instance running an app process in the same system, in the same server. I want to create a container and run it, right? But we are talking about GitHub, Docker Hub here, right? So, these images can be pushed into the registry, keep it there. Whenever someone wants it, they can pull it and they can run it wherever they want. Let us say this was UAT environment, this was dev environment, somebody else wants to pull it and run it in SIT environment, wherever you want. You go to GitHub, this Docker Hub registry, take your image, put it into container and run it. Okay. So, this is the concept of Docker Hub. I can store images here. Whenever I want, I can pull it, or once you want to update something, you can push it always, right. So, this is about the Docker architecture. So, these components are part of this Docker architecture. Additionally, let us see some simple command, because I am giving here some commands: Docker run, Docker build, Docker pull. What are these? So, let us understand those Docker commands, right. The first one is Docker run. It is used for launching the containers from images. Okay. Docker run, it is used for launching the containers from images with specifying the runtime options and commands, right. So, Docker run is used for launching the containers from images. That is what, no, the sequence is code, then comes the image. Once you have an image, you can create a container. Okay. So, once you have an image ready with you, to put this into a container or to generate a container for this image, we can use Docker run. Then Docker pull, it fetches the container images from a container registry like Docker Hub to local machine. Same like our GitHub, getting the code into our local machine, same way we can do the Docker pull here. So, once the code is available in the registry, I can use Docker pull to fetch that code into my local machine. Then the third command is Docker PS, right. It helps in displaying the running containers along with the important information like container ID, image used and status. Okay. PS is like our ls command, ls. It will show you all the available files and directories in the folder, right. Same way we have Docker PS. So, once I give Docker PS command, it will show all the running containers along with their container ID, and in each container what is the image, what is the name of the image, some details about the image and their status, all that can be known to us using Docker PS command, right. And then the next one is Docker stop. So, if you want to stop the running containers, we can use Docker stop. So, what it will do? It will stop the containers from running. Okay. So, it helps in halting the running containers gracefully, shutting down the processes within them, right. So, again the sequence: code, the image, this image I will push it into a container. Container is a process, it is a process which will be running always. It means it is control is with us to run or to stop, right. So, stop command is used to stop this process. Then we have Docker start. So, it is help in resuming the operations from the previous state. Once if I want to start a container, If I want to start a container or restart a container, I can use docker start. Means this code will be running state, right. Then we have docker login. It helps to log into Docker registry, enabling access to private repositories. Okay. So, in your Docker repository, you are having lot of images. So, if you want to check what all images you have created, you have to use docker login command, using which you can open the registry and see what all files are available there, what are images are available there, right. So, this is about the Docker architecture, because why we are using some commands here, docker run, build, and see docker build is used to create a build like this, using docker file plus the code. To generate an image, we use docker build command. Okay. There are so many such commands. I have just discussed a few important ones, but like Linux commands, Linux based commands, we have so many commands here in Docker. All that we will try to execute, right. So, this is about the Docker architecture.